All right, so good morning to everyone. We are happy to welcome you here at FANUC, or maybe in the Teams chat. We are going to show you today a little bit the newest technology when it comes to robotic welding training with a FANUC cobot and our Soldamatic. So with me today, we got our product manager, Ignacio Salvide. Want to say something?
Yeah, good morning.
No? Good morning.
Thanks, Jens, for letting us being here. It's a great pleasure. Thank you.
And further, we have Jens Mühlek here. He will say some words about himself later on. But from my side also, thank you for letting us do this.
Yeah.
All right.
Thank you, Asa.
So we can start with the agenda. Maybe a little bit about the agenda of today. We have, we almost forgot. We have one more person in the room with us in director position, our colleague Joachim. So when something's not working, it's his fault. And if you have any questions, you can put it in the chat and Joachim will ask us. All right? Good. So continue with the agenda. Yeah. Okay. So we're going to start with who we are and what we do, a little bit about Seabery and a little bit about FANUC. And further, we'll continue with the context and trends. Then what we do to counter these trends. Then we are going to have a look at the Soldamatic, especially the robotics and some references. And then the most important part, the live demonstration of this technology. In the end, you will have time to ask some questions and we will probably be able to answer them. All right. So I'll give the presenter to Jens.
Yeah. Hello, everyone. Thank you also for coming here to us and yeah, to show us the Soldamatic, to connect the Soldamatic together with our FANUC robots. At first, yeah, my name is Jens Mühlek. I'm here in FANUC, the business development for education. So I'm here for teachers and for schools, for the apprentice guys. If you want to do something with robotics, I'm the right guy. At first, I want to say something about FANUC. What is FANUC? For you don't know what FANUC are. Yeah, we are the factory automation company. We not only have robots in our products. We start with the CNC controls. We build our own servo motors, servo amplifiers, and also lasers. Then we go up to the industrial robots, the cobots. Also, yeah, accessories and software for that, but also wire cut electrical discharge machine. We have vertical machine centers and injection molding machines. So we have not only robots, we have a big portfolio. Yeah, but today we only see our robot. Yeah, and then at last, yeah, we come from Japan, so we build everything in Japan and send them to the world. And here are little numbers what we are make the units per month. So I think the interesting here is the number for the robots, that we have more than 50,000 robots per month. So yeah, I think it's a nice number to see. Yeah. Okay. Yeah, that only a few words about FANUC. If you have any question, I think we can go on later on which robot do we use here, and what's possible with them. We can, yeah. If you have any question about the robots, we can ask after that.
Okay.
Okay.
Thanks. Yes. Okay. So now I'm going to spend a few minutes talking about what we do or how we do. We are Seabery. We are an international company based on Spain, Germany, China, and US, with the goal of revolutionizing skill-based training with AR, but basically with our technology. Our technology is being used in more than 80 countries, and we are thousands of customers worldwide. Now I'm gonna try to play a video where we want to show how we do things and what we do. Okay, so Joaquin, let's try to play the video. Not working. Okay. It's a 3-minute video, okay, but it's quite nice how we want to change the training, the skill training in the world. In this case, it's with welding. We have started with welding with Soldamatic, but we want to continue with other skills training in the future. Okay, now it seems it's working.
Steady, slow, here I go in this skin.
The job market needs qualified professionals. Without a doubt, we need a more efficient training system.
Holding steady. I see my fear, but I am not afraid. Reaching the high up today.
So now there is a new hyper-realistic technology based on augmented reality, and it is revolutionizing professional development in construction, in factories that build cars, trains, ships, or airplanes. We will always need qualified welders. This is a profession for the future, more attractive and more attainable than ever, thanks to Soldamatic.
Here I go, here I go. Ooh, The path I'm on, the one I chose, by myself, but not alone. I am ready, holding steady. I see my fear, but I am not afraid. Reaching the high up today. Here I go, here I go. Ooh, ooh. I've been running for so long. My heart is beating like a drum. I live my dreams, I don't give up. I don't give up. I won't give up.
Okay, well, I hope you see how Seabery want to change the skill-based training, because we believe the way that they have been done during all this year is not efficient. But now we're gonna show how and what we use to change that that skill training base. We have Soldamatic, which is our welding training solution. We use Augmented Reality, hyper-real sim, state-of-the-art solution. With that solution, what we want to train in this case is welding. Okay. About the content, it is general knowledge that there is a global shortage of welder. Is documented and is increasing. It's also known that traditional welding training is inefficient, costly, risky. But also we know, we have seen that new generation demands different ways of training. They are not used to doing in the same way, that things were doing in the past. Okay, they demand new things. Industry 4.0, productivity, digitalization, environmental friendly, all these topics are trend nowadays in all the companies, in all the group areas. But in robotics in general, what we see is an increase of welding, expected to be around $10 billion by 2026. This is documented. This is information that you can Google it if you want. Also, we see that industrial sector companies in general are just growing faster in that way. So they are buying robots, but in the educational sector, we don't see that. So they are just, let's say, a little bit behind of the industry. So we need to close that gap. And then we have a shortage of welder, but also we have a shortage of operator. So we need to create a solution who can just manage and to solve these two problems. So with this, our goal is to create a new market. This is something that we need is going to be difficult, but we need to engage the most important stakeholder, like welding association, companies, government. We need to engage everyone in this common goal. Okay. To get that goal, we see three challenges. Okay, we see that in the past there wasn't any scalable and mature enough solution with Soldamatic, and for example, this row we see that we have a good solution. There is not any robotic welding standard in the market. There are many private content, but there is not any standard. Okay, so we need to engage. And that's what we are doing, in fact, with different welding association. But also the last and not least important point is about the training. So we need to give the end user a comprehensive solution, hardware and software, content, and training. Otherwise, they will not be able to use the solution and it will not be effective. So with this challenge, we are going to work, and now I will pass the rest of the presentation to my colleague Lucas with three pillars. The first pillar is hardware and software solution. We have Soldamatic, which is our AR simulation with the robot. Then we will talk about content and certification and also trainer. Okay, so we are going to focus on these three pillars. Actually, we have been working in the past, but we will continue working on that. So now my colleague Lucas I will give this to you. We'll start with
So thank you. As Nacho already told you, we are talking about three pillars, and all these three pillars will come into our augmented methodology. What you see right now is a classroom with a trinity on the right side, where we see on the left side the actual simulation for the manual training as well as the robotic training. And on the right side, in the real workshop, the actual practice workshop. So what we have here is a system where the simulation is used as a training for the real practice. And inside of this, we will have the materials which are necessary and actually they are not existent right now. So we are working on having a content to learn all the skills and all the theory you need for the actual practical task. And all of this inside of a classroom and then further into the practice workshop. So this is more or less the three pillars inside of a training center. And this is what we want to do with the solution. So next up, we have a quick video about the actual robotics, not the Soldamatic in general. And director, press play. So again, this is a video which needs a slight buffer time, but you will see the product and how it works in a few seconds. So yeah, there we go.
In the industrial sector that accounts for 25% of global GDP, companies continue to struggle to find qualified workers, especially welders. Industry 4.0 increases the pressure for automation and optimization, while traditional methodologies do not fit their current needs. Robotic welding continues to grow, and industrial companies need workers with welding knowledge and robotic programming, but current methodologies and trainers are not prepared for it. There is no standard training or formal curriculum for robotic welding. Furthermore, traditional methods in this type of training are expensive and inefficient and do not follow the latest trends in simulation and environmental impact. Soldamatic Robotics is the world's first solution that offers scalable training combining robotics and welding thanks to augmented reality technology. This patented solution enables students and professionals to train in robotic welding using real equipment for programming exercises, reducing costs, materials, and pollution. This next-generation technology provides the most realistic, complete, and flexible robotic welding training solution. Furthermore, thanks to its extensive catalog of parts, it enables training for students and professionals for different industrial sectors and provides a complete view of the welding quality thanks to its exclusive analysis module. Soldamatic Robotics includes robotic welding content that combines theory, exams, and practices, and also allows you to upload your own content. Just like a real welding machine, Soldamatic Robotics can connect with almost any robot on the market, thus adapting to the needs and facilities of training centers and companies. The analysis module enables you to reproduce the welding exercise at any time and also allows you to analyze the section cuts and the mechanical resistance at each point of the weld seam. Thanks to Soldamatic e-learnings, trainers can reproduce each exercise and manage all their student courses, whether they're students or professionals. Soldamatic Robotics is revolutionizing robotic welding training for Industry 4.0. Whether you already have robotic welding training or not, if you're interested in taking your students to the next level, contact us.
Okay, so in the end, it trickles down to the same things we want to reach within the manual training. More engagement, decrease of costs, more time on the actual arc, and more certified operators in this case. Yeah, so everything we already do in the manual, we want to combine with this solution. Okay, so maybe a few things about our new system, some new functionalities before we show them in the live demonstration. We have a so-called virtual view where you can see from a certain point of view what the robot is doing while you are welding. So you can not only see from top, so you also have a virtual view from the side. This makes it easier to see if you hit the right path, if you hit the rule, and you can teach more easily. Afterwards, the analysis, we're going to get a closer look later on, has some new functions. The measurements inside of every point of this welding bead, and also the mechanical resistance. On the bottom left corner, you see some more coupons. Actually, the catalog is growing. So we have typical exercises for robotic training from different countries and from different associations. Okay, so these are a few of the new functions. You're going to see them live. What you already know is the e-learning. Meanwhile, we have a web access. So if there's no possibility to install something in your company, you can just access this via browser. All the exercises are saved as well as in the manual. Further, some new functionalities in there. It's easier to set up, which is an important part. And you can create diplomas further than the reports you had in previous versions. Okay, so what my colleague Nacho already talked about is the welding certifications. We are in touch with the most associations to create content, which will be certified. So this is an important point. When you don't have the content, hard to train someone. Yeah. Good. Also, the train the trainer is in the works. You see a picture from the Spanish Augmented Lab, where also the teacher gets the knowledge to teach with this solution. So without knowing how to operate this whole solution, there's no point in showing it as well. Okay, some of the clients, I think we will skip this part, and we will go to Camp University. I've seen Mr. Vogelei in the chat, so hello to you. And you can see those references on our YouTube channel. We're not going to look at them.
Yeah, now let's go to the live demonstration.
We are going to the live demonstration. I can't skip further or faster. There seems to be a problem with this pointer.
Yeah.
Okay.
So
So
you guys doing the live demonstration. Okay, I'll be with Joachim.
there we go. All right, so we're going to start with the Soldamatic real quick. As most of you probably know this solution, so I'm just going to be very, very quick. It's our welding simulator right now connected to the FANUC CRX. We have two connections up and running. One of them is in the front. You see the connection to our torch. The torch has a camera inside and uses our markers as in the manual system. And the second connection to the actual robot comes from the backside. It's the Ethernet IP connection where we can send signals back and forth for exchanging job number, for starting the arc, and so on. Yeah, so this is the Soldamatic part. And yeah, I will give the word to Jens to explain a little bit about the FANUC part.
Yeah, here we have a CRX, our collaborative robot. Here we have the CRX 10. So we have a payload with for 10 kilograms. Yes, and our collaborative robot, but the solution is also working with the normal industrial robots. The collaborative robot, you have a tablet. On the tablet, we have a normal app where we can start and program the robot. So the programming is very easily. I can show you a little bit later the details how you can program it, but it's very easy with drag and drops. Per drag and drop, you can teach the robot and make the function. Yeah.
All right.
Okay. So
a little bit about both of these tools, and now we are going to start with the actual practices. We prepared some things, and in the end, we are going to do a little bit of live action where Jens is going to show us how to program further tasks. We're going to start with something very easy. And you can see the Soldamatic menu on the top left corner. We're now going to just create a simple task. You see our butt weld here, and Joachim is very quick, so great. We're just going to weld one bead in 250 millimeters with the CRX, and we're going to set it up, and Jens is going to start the welding. So we'll just choose a robotic task. You know this menu probably, and we can select different levels here. The training is, most of you know the training part. Advanced comes with some more different coupons as shown in the presentation, some for every welding association, and there will be even more. Okay, so we'll stick with the training for now. Go with the butt weld and select the position, the material, the thickness, as you know, and the wire and wire diameter, and also the gas. So first part is done. Now we know that it's a 250 millimeters welding bead. One pass for now, straight, continuous, push, and right to left. So this is all the information I put in here. I could also create this task in the e-learning software and just start it. But we want you to see what is possible. So we go through this, and now we have our WPS. We will start, and then we'll change into the camera set of the robotic torch. Should be starting soon. Yeah, sure. So this is what the robot sees actually. You have indicators on the top left corner. This is exclusive for robotics. So in the manual training, you don't have these indicators. They help you with the teaching quite a lot. So you can see the distance, the angles, and with this screen, you can navigate really quick into a good position. Further, you'll find the angles on top of the nozzle and also the distance with the green and red indicators. On top, you see a job number. You can create jobs in here, and you can select them with the control of the CRX.
Yes.
So, for example, we have different jobs here, and Jens has selected a job for this task, and the CRX will send it to the power source, and hopefully we will have a good result in the end. Yeah, so I think, Jens,
Yep.
just let it weld a little
run.
bit. I hope you can hear it while in the middle of this layer. We changed the values. So one part of this layer will be fine, and the other one won't be that good. So we'll see in the, yeah, perfect. So you see now in full screen what happens when you select the wrong parameters. Yeah, we can see it from the side. We can rotate this view, and this is our result. Yeah. This is only the 3D view. What we now are able to do is to get into our analyze tool. So same procedure as in the manual. We are able to fetch the exercise report. So we tried this a couple of times, but I think it's frozen. You can see it. Okay, Joachim, good job. You can see it now. On the left side, you see the parameters are fine. On the right side, they are highlighted red. So we changed the job almost exactly in the middle of the welding bead, and on the right side, we have the wrong values. So this will be not very good. We can also see the defects. There's spatter on the right side because of the wrong values. And you're now able to go through the whole welding bead, have the values on the left side for every single parameter. You can change the view. Also have the cross section of the right part. You see the measurements on the left side. And then when we change the job, you see it almost doubles in size. And this is how we want it to be. Yeah. Also, it's possible to just go into a replay where you have the normal side and also the virtual view from the side. This is pretty good. So the root is almost perfectly hit, and you will see the change of the arc in a second. Okay, you can see it, you can hear it. They don't hear this? Okay, you don't hear this, but the sound changed also. I'm not able to reproduce it, but you can trust me. Okay, so this is the possibility. You can train in an easy way. You can change parameters and see what happens. And we also have the possibility to produce more errors or to try more things. What we set up for the second task is kind of the same workpiece, but this time we work in 3 layers. Right now you can see the one layer with the different parameters, and in the next task you'll be able to see how the layers are added up. Yeah. So it's very important when you do a multipass that you hit the right angles, so the layers are above each other. But we're going to see. We'll make this live and create another task with the butt weld. Same position. We're not going to move this. And with a wire. And this time we're going to use 100 millimeters of length and 3 passes. So you can see already they should be added up. Same technique, push right to left. And then continue. Okay, WPS, work angle should change from 1 to 2 to 3. And hopefully the robot will manage to do this. Okay, I'm going to hit the augmented reality button. So we can see our welding lead. Okay, Jens. So number 1, root layout. I will bring the microphone a little bit to the helmet so you can hear something. Yeah. And for the second and third layer, we're going to change the view a little bit. We're going for a virtual view. This is something we can do while welding. And now you're going to see a different angle. Yeah. With this close-up shot, you can see even better the distance if we hit the right angle and also the actual arc. And number 3, angle looks good as well. Seems like Jens did a good job. So this is something new, even though we don't have a camera included on the outside or somewhere here. We can change the view in a virtual way. So it's quite nice to see more of the actual root of the arc, and you are able to witness everything in detail shots. So again, here we have the possibility to get into the results. This time it works directly. Very good. And there's a lot to see now. On the top, you see pass 1 of 3. And one thing we can notice directly is the score of 100 in travel speed. So this is perfect. We don't need to change anything here. The distance is almost perfect as well. And the aim is only off a little bit. You can see it's going a little bit off the perfect dotted line, but only a few millimeters. And this is, I think the workpiece is not fixed perfectly, but this is okay. Travel angle is a little bit too steep. We can work on that in our next try, maybe. So this is what we actually want to achieve. We can see the travel angle is a little bit too steep. Let's go a little bit more neutral. Yeah. So this is layer 1. We can see layer 1 in the different views as well, cross section. And what's more interesting, we can go for layer 2, and we can see again travel angle a little bit too steep. The work angle also a little bit too far from the perfect position, and also layer 3, where we have the perfect travel angle, but the work angle is not quite correct. So a few things we can do better. And also we have the possibility to go through the cross section. And what we see now is actually what we wanted to see. They are not added up perfectly with each other. So pass 2 should be the blue one, and pass 3 is the, I don't know which color this is. To be honest, it looks yellow, a little bit yellow brown. Yeah, whatever. You see the measurements, and you see how these layers add up to each other. And in a perfect way, they would stack. So we have more power behind this connection. You're also able to just go through the single passes in this way. Add them up to each other. And you're able to replay every single pass. So this is now pass number 2, which was good. So we can skip it. And when we go to pass number 3, we will see one thing. So this is not the best. Could be a little bit more into the center, right?
Yep.
But overall, a good start. And now I could start tuning a little bit. Yeah. So endless possibilities to try out things, to make mistakes, and to learn in a non-risky environment without using any gas, any filler, or any real material. And all of this is secured on the database of this unit. And when you have a student trying out different things, it gets saved into their map. So you can see student Joachim has done a lot of work. In the end, he's got a good result. With one parameter, he has some problems. I can teach him a little bit how to change the speed, or to use a different job number or whatever. So transparency for the teacher, and a lot of things you can do. Well, so this has been a pretty easy task, I would say. 1 layer, 3 layers. We have one more workpiece here, which is out of our advanced catalog. You see the AWM001, which is a ambidex. So you have to do it in manual with left and right hand. It's not that easy. For the robot, it doesn't matter if it's right or left-handed, but it's pretty hard to come into these corners. So you want to be in this corner and go upwards for the first 2 sequences. Then you have one more sequence which goes around the tube, and 2 more sequences within the obstacles. So the major task is to get into these positions in the right way. What we did so far is just to program the first layer,
Yeah,
right?
this one.
which is on the backside. You will see. And we will let the robot do the first layer, and then Jens is going to show you how to program the second. So this is our live action now. I'm going to start the task, and I'm going to give the word to Jens.
Yep.
The detail shots.
Yes,
Should
I can show
you
you.
do it? Okay.
Yes. Yeah. Yeah. So at first, can show you the program. So here you see the tablet with the buttons. So we have here the program in this way. I explain what means everything later and on the second pass when I do it by myself. Yeah, and here you can see the start screen. So if we want to start the program, we say okay 1, and yes, we are sure to make it, and then the robot is moving to the right to Angel, start welding, and then goes up.
Robot's pretty quick.
Oh, too fast?
No. It was
Okay.
the perfect timing.
Okay.
But I think we moved the torch a little bit. So maybe we need to fix that.
Yeah.
So you can see now how the robot tries to get into the corner, and the orientation changes to go upwards. After like the first few millimeters, you will be in the right angle, but it's not that easy to program.
Yeah.
But some difficulties are a bit more challenging and make more fun, I think.
Yes.
So
Sure, yeah.
just programming a butt weld, something everyone can do, but here you need to have more time and experience. You
Okay.
want to include the shot of the Soldamatic as well? Okay. So I don't know. I think you have to run it again to start in the corner.
Mhm.
The program wasn't fast enough. Okay, so now we will run it again. You will see it with the augmented reality.
Okay.
And yeah. Yeah. I think we moved it. Ich glaube, wir haben das ein bisschen verschoben mit der Torch. What you can see now is due to the fact that we moved the torch slightly, we are not perfectly in the seam right now. Hopefully it will still finish this task so we can go to the second one. But if not, we're just going to try to move the torch a little bit in the starting position.
Yeah.
So this is actually what we wanted, some live action. Here you got it. You also see the texture of the AWM. The look is quite more realistic than the standard pieces, but it's okay. Yeah, it's not exactly in the seam, but it finished. And what you can see now is on the other side, the second layer or the second pass, which is more or less the same, but you can get into the corner a little bit better, right, Jens?
I hope so, yes.
Yeah. Okay. So maybe we'll do a mix of this shot and augmented reality. Yeah. Okay.
Okay. Oh, I think first on the phone. Yeah. So phone, then I can show. So yeah, it's a collaborative robot. So we have the possibility to move it by hand. Yeah, it's up to you if you use it by hand, moving the robot with the buttons here. Normally, it's a mix of both. So at first, I think it's
Take the phone.
Yeah. First, I go to the manual guided teaching, says 3, and then for here it's more easier to use both hands, so I can say, okay, freehand teaching. Then the robot is you can show the light on the robot. When the robot is blinking with the green light, then he's ready for the freehand teaching. So I can put on. Oh, what's the better is I show you. I make a new program and teach also a name that we find it in the beginning. So at first we teach the starting position. Yeah, with a point we go to the hand teaching mode, and then we only have to put the button and put it up.
Drag and drop
to the program. Yeah. Then now we can move by hand the robot in our position. Normally I'm searching for the starting position. I was a little bit too strong. And then I go from this position back to the start position. So it's more easy, I hope.
Joachim, can you have the exactly?
I can see it.
So we included the picture of the robot's eyes for Jens to have a better orientation. So
okay, so now I switch to the mode because I also you have to see the I use the angel I use the buttons to go.
So we're getting to the starting point closer and adjusting the angle.
A little bit more. Sagt er schon mir mit.
And you see, it's not that easy getting into this tiny corner with the torch. So this is the most difficult part.
No. It's not so easy.
Yeah, that should work.
So it's good.
Yeah, if you can go a little bit more to the center.
Yes.
So it's a mix of using the tablet. Should I? What we can also do is rotate the camera. Jens, give me 1 second.
Yep.
Just a matter of rotate vision module, and then we see it from this position.
Yeah.
Maybe it's easier.
So I think cannot go more to the left side because we have a collision. But now it's good.
Yeah, it's fine.
So yeah, I go here to say that's my point.
Yeah.
Okay. I say, okay, this is my point. I want to start later. So I go up to here, and now I finished the welding process, and then I go back to the starting position and go from there to my first position. So yeah, it's more easier. Okay, so if we here, now we want to start. After that point, we want to start our process. So we need the communication to the Soldamatic. So we put an output here, and we start with the output 113, and put this to off, from off to on, and then the robot starts.
So this is now the mapping and the signal, the digital output 113 or 112, starts the actual arc.
Yes. Before we start, we want to set up the right job number. So we can say, okay, we have also, we give the job number from the robot to the Soldamatic with a register. We can put this in the font, and the right job number is our register 1, and we say the job number what we want is
118.
118.
So this is something you can do on the Soldamatic or on the teacher software.
Yeah, and then yeah, we are ready to go up. So I'm hope that I can program it so good. So I'm moving in the Cartesian position, and go up with Z. A little bit. So, and then the best way is to move also the torque a little bit. So we see if it's possible. So different from here to the first exercises was that we cannot make only 2 points from start to end. So we need some points between, and we hope that the robot is not into a limit. It looks that the axis 6 is in a limit. So I go to I have to put it.
Now we want
By
to
hand.
go more into a push position. Adjust the travel angle so we push upwards. And the problem is, in this case, in the starting position, you're not able to push further. So you need to do it while going upwards.
Okay, so now I see that I have to go more position. Yeah, the problem is that my axis 6 is on a limit error. So it's not the best position for everything, to move everything. Okay, a little bit more to the left.
Okay, now it works.
Okay, so now it works.
So this will be a waypoint.
We need a little
bit more distance.
More, it's not possible because I have a.
It's fine.
Okay. Yeah. So then we put the next weld point here, and then I think we can go. we can go up.
A little bit further. Okay, that's it.
So,
Okay.
okay, I had my head before. Okay, is it good?
That's perfect.
Okay, so yeah, then we say, okay, this is our next point. After here, we want to stop the welding. So we put the next output signal in here and say, okay, from this output, here we see output 130 was on, and here we put 132 off. So, okay, and from here we go, there we go to a position out of the part. So we can say, okay, from here we go outside in this direction, and then oops, to this direction.
That should be fine, so we can see the welding bead afterwards.
Ah, okay,
Yeah.
perfect. Okay, so we stop here. You put in another point. Yeah, and then now we want to come to this first position. Now I can run the program in back way, so backwards. So I go to this position and say, okay, step by step, go to this position. Then the robot is moving to this position. And so we go all the way back.
Next point. So we changed the orientation. You
So-
see in the bigger picture.
Yeah, and from this point, I have to put in another point, because from the starting point to this point, I cannot go directly, or I don't know if I can go directly. So it's better to make a point between them. And then, yeah, go to the left. A little bit higher. Okay, and then I can. Okay, I think from here, I can go down. So I put a point before them. Okay, and then, yeah, at first step, we can move by hand from the starting point and look if we have if everything works fine. What we have to change after that, when now I go away of them. Okay, so it looks good. We have no.
The speed is a little bit too high.
Yeah,
but
the speed is. This is what I want to say. After that, when everything is good, we have no collision. We have to change the speed for the welding process. Okay, so yeah, should we start? So
yeah,
okay, yeah.
Let's do it.
Then we start the first time with the wrong speed, and then I can show you how to change the speed.
you want to do this side or the first side as well? This side is sufficient, I think. We can clear the last one.
Yeah.
And then we can start it. There you go.
Okay, so this side?
Yeah.
Yeah. Okay.
Then we can jump into the questions. Because our time is running. I didn't see it as well, but
Okay, no problem.
okay. So Jens, good job in performing this in a few minutes. I really like this view. Great. So we are at the end
Yeah.
of our time. Thanks again for doing this live on the go. This is I don't think it's that easy. Then X6 is not going any further, and you have to find a different solution. But
Yeah, this is also if you start to welding, you have to see if you can move everything, and
yeah.
So
exactly.
this is one of the important things.
So same problems as in real life welding and robotics, but I think that was a brilliant showcase to see both of these devices in action.
Yeah.
Okay, so Joachim, do we have any questions? So now, no questions. PowerPoint. Is there anything left?
Yes. I see. Maybe one question from that one. I'm not sure if it's ready to send, but maybe you can use the chat. Maybe not sure.
I cannot see any chat.
Yeah, but nobody can hear me, so you have to say it.
Roberto, any question? Chat or microphone, whatever you like.
So please use the chat because we don't know if the microphone is working.
Okay, so if there are no more questions, I would like to say thank you again to Jens and to all the participants. Thank you for taking your time and having a look at it. It's a brilliant solution. I think it's really great. If there's any questions afterwards, you got all the contact details. So feel free to get in touch. And yeah, that's it from our side.
Yeah. Thank you.
Bye-bye.
Bye.